Hello guys, we are a farm in arid campus. My name is Dennis and we are going to visit one of the ICA students called Andrew and see how he's doing with his farm. As you can see, the farm is around, I think, 30 by 15 meters. We shall ask him well, I'm not so sure. And you can see that the maize is grown. I think he's in the process of harvesting. We decided to visit him and talk with him about his farm and share his experience about his experiment and get some knowledge about how all this was done. He's here weighing some things. Hello, Andrew.
Okay, Mr. Dennis.
How are you?
Fine, how are you?
Good.
Yeah.
You can introduce yourself a little bit to the people before we start passing through your farm.
Okay, thank you. My name is Akana Andrew.
Yes.
I'm from Uganda. I'm doing a Master of Science in Climate and Society with specialization in climate science. So this is my thesis,
Yes.
the experiment on the maize
Yes.
with varying fertilizer levels.
Maize. Why maize? Why did you decide to choose maize?
Yeah, if you see in Ethiopia, this is actually Tigray region.
Yes.
So if you see in Ethiopia, basically like in Tigray region, among the four major food crops in Tigray region, we have maize is actually the second. No, it's not the second. It's the second in terms of the cultivation, in terms of the area coverage. It's the second, but in terms of the in terms of the
Good. In terms of what?
in terms of the in terms of the area coverage,
Yes.
you find that maize
Yes.
is the major. It covers the largest area of land, but if it comes in terms of the food security,
Yes.
maize is one of the most important food security, not only in Tigray or in Ethiopia, but in the whole sub-Saharan African countries.
Okay.
So that's why I try to source maize. Then secondly, there are a lot of varieties which the breeders have come up with which are a bit drought tolerant. That's why I'm also trying to do on maize.
Okay.
Then also if you look at Ethiopia actually in general, they have a lot of livestock. So in most part of the countries, they also use this maize as part of for feeding livestock. So it's a very crucial crop, not only in Tigray region or in Mekelle, but in the whole of Ethiopia. It's a very stable food crop.
Okay, thank you. So we can see on the process of harvesting, but first of all, take us through the whole process. How you started. Let's start from the beginning. Tell someone who does not know anything about this how it is done.
Okay. This is a research. The main objectives of this research is actually to compare drip and furrow irrigation with respect to maize and a different a blended fertilizer level. The blended fertilizer level is actually the fertilizer which has been designed by the Atlas. Atlas is actually a Tigray agricultural transformation. So they have come up with a blended fertilizer which is called nitrogen, phosphorus, sulfur, zinc fertilizer. So I'm trying to use this fertilizer. It's not yet a common fertilizer for use by the farmers. So that's why I'm interested in. So I want to see that this fertilizer I compare with the drip so that we see which level of fertilizer actually the farmers can adopt and which method of the irrigation maybe they can adopt suitable for Tigray region.
Okay.
Yeah.
So in the beginning, you use seeds. How do you plant this? Your maize.
Yeah, this one the maize we obtain it from Mekelle
Yes.
station, research station.
Yes.
It's called Melcasa 4.
Yes.
So this is Melcasa 4, and we try to use furrow and drip. So if you, as you can see, this is the barrel for the drip. So there's a tap water there. However, you find that the tap water that we have here, the water in Mekelle is very hard. It has a lot of salt. So this is for drip, and then this is the furrow. So for the furrow, we fetch the water from the tap direct to the furrow. We have a way of measurement. We measure the quantity of water for the furrow, then quantity of water for the drip, in order to attain the yield. So that at the end of the research, I want to know how much quantity of water the furrow has used, then how much quantity of water the drip has used, under different fertilizer level.
Okay.
So if you look at this one, after the first subplot, that one is the first subplot.
Yes.
In that first subplot,
Yes.
I put 20 gram of the blended fertilizer, that is nitrogen, phosphorus, sulfur, and zinc fertilizer. Then under this drip irrigation, there was no fertilizer applied. Then in the third subplot, in this plot, there was 10 grams of the fertilizer.
Okay.
Then if you come to this one, this is furrow, there was no fertilizer.
Yes.
Then in the middle, there was fertilizer, which is 20 grams of the blended fertilizer. Then at the last plot for the furrow is 10 grams
Yes.
for the fertilizer.
Yes.
So this is actually first replicate. We replicated the experiment 3 times in order to avoid the errors. So this is the first replicate, there's a second replicate, then the third replicate.
Okay.
To ensure that there's no error during the what? To actually try to reduce on the error. So that if you find the result from here, you compare with the result in the second replicate, as results in the third replicate, so that you try to reduce the error.
So how long has this taken?
Yeah, this Melcasa 4 variety I planted on the 4th of Feb. Today is the
20th.
the 20
20th of,
the 20th
of June.
Today is 20th of June.
Yes.
So it's around 5.
March, April, 4 months.
It's
and
around
something.
it's around 4 months or something. Basically, this maize was not supposed to take up to this duration of months, but because of challenges, one, the water is very hard. The water is not soft water. If it was rain, it would have come very fast. Maybe it would take like 3 months, but because of the hardness of the water, it has come up to maximum of around 4 months. Then also, this one is not a rainy season. That's why we are trying to use the irrigation. So this is in this season there was no rain, so you find that we had a lot of challenges in this research. Okay.
So tell us about these buckets. It's as if you're harvesting, but they're in different buckets.
Okay, right.
They have a meaning. What do they stand for?
Yeah. Okay, let me tell you, this one is actually the harvest, is the yield.
Yes.
5 plants per plot. I was taking 5 plants per plot. So these are the yield of 5 plants per plot. I want to take the average so that I try to estimate the yield for the subplots. I was taking the 5 from within the central of the plot to avoid the border effect. So these are for the drip. This one is for the furrow, and then this one is for the drip. So as you can see, I have a weighing scale. This is the weighing scale that I want to use for weighing. So if I was trying to weigh, we can try maybe like for this one. This one, no fertilizer, drip. You can see it's weighing around 2 kilograms. It's around 2. Yeah, it's around 1.8 kilogram. This is drip without fertilizer. Then if you compare also for furrow without fertilizer, let's see, it's around 0.9 kilogram. You see, there's around 0.9. So I'm trying to do a lot of which I cannot tell you all. I'm trying to do a lot of calculation and see which one is actually better. But basically, from this that I've shown you, you find that drip has actually given more yield than the furrow.
We also see a weighing scale.
This one is
the
tape
meter,
measure.
the tape measure.
The tape measure is actually, I'm trying to use it for measuring the diameter of the cobs.
Yes.
Then I also use it to measure the length of the cobs. Okay. So that I try to evaluate which one is actually giving a more yield than the other. Then I will also consider the cost of production. So at the end, I will evaluate which one is more feasible, is more economically feasible on the production, because I will see the yield, then the cost. However, cost, there are two types. We have variable cost and the fixed cost. The fixed cost, like for this one, like the drip facilities, once you have already acquired, you can actually use this one almost for like 10 years or even 5 years, for more than 5 years. Okay. So you can keep using them. So you find that I will actually dwell much on the variable cost. Yes. Maybe the cost of the fertilizer, the quantity of water, in order to evaluate the economic feasibility. Okay. So now, later on, I will tell you which one is so much recommended so that farmers can adopt. Which one is more economically feasible and give high yield so that the farmers can adopt.
It's a very good study that will help our farmers.
Thank you.
So now, like, what are the challenges? What are the challenges that you meet in such kind of work? Or you have?
Yeah, there's challenges, especially in dry season. There's a lot of challenges. Number one, especially for this experiment, which I believe also other farmers also do experience the same problem. Number one, we have a lot of problems like the animals. The stray animals like the cows, like the goats, they would come here.
We can see your plot is fenced.
Yeah, that is why we fenced. It was a bit costly, so that's why we try to fence, because the cows can actually come in to come and eat. There's no grass, all the grasses are dry. So the cows, the wild animals, like the porcupines, was also eating also a lot of the maize. So that's why we try to fence.
We see some.
You can see we try to dig and put a fence in order to reduce on the stray animals. Then another problem also is the water. Water is a serious problem. That's why I'm trying to compare furrow and drip, so that which one combined with the fertilizer level, which one will be more economically feasible. Because I'm trying to say drip is known for water efficiency than furrow. But I want to combine with the fertilizer so that I see which one will actually bring more yield, because this is a new fertilizer which is blended. So I want to see which one is more economically feasible, so as to reduce on the to increase on the water use efficiency for the maize. Then another challenge also the cost of the what for the drip, especially the cost of the installation is high. Also the maintenance. I'm not a skilled person in the maintenance and design of the drip, so I've been experiencing a lot of problems, especially with the drip. If you are not a technical person, or if you don't have experience, it can bring a lot of problems. For example, you find that even the filters. This is the filters. It can get blocked up. So once this one is blocked up, the water will not go in the drip. So every time you have to come and clean this filter. So if it is not clean, you find that your maize will be there, but the water is not going. So you have to clean the filters. Then also this one, these are the lateral lines. They have holes where water keeps coming to the maize. It drips slowly. But now, because of the earth water here, these holes sometimes they get blocked up by the scales from the water. So it's also another challenge. You need to keep flushing them.
So do you think it affected your harvest in some way?
Yeah, probably it's one of the errors. Yes. And it's one of the errors. That's why we try to replicate in order to minimize some of the errors.
Okay. Yeah. So what advice can you give? What have you learned from all this? As a scholar, what can you tell farmers, maybe scientists, maybe ICS, anybody?
Okay, thank you. I can tell actually a lot. Because if you see for us in the...
So far, because we know you have not got the final results, but just from the experiment going on.
Yeah, I can see, especially I'm impressed with the yield.
Yes.
I'm a little bit impressed with the yield.
Yeah.
However, there was challenges, but the yield was actually a little bit better. If I try to extrapolate it to it in terms of acres, it gives a lot of yield, especially if you combine the fertilizer plus the drip. It gives a lot of yield, which if you extrapolate in terms of acres is actually a very good business, especially in the sub-Saharan Africa, Ethiopia inclusive. You find that the major problem is food, especially now when it comes to the off-season production, like in the dry season like this. So you find that the the major problem is food. So if you have a constant supply of food, maybe during the off season, during the dry season, it's actually very good because it can actually improve on the nutrition and everything. So I actually advise farmers and everyone else who maybe is watching me, farming is good and you should actually try to adopt irrigation method because we are facing a lot of climate change. There's a lot of increase in temperature. There's the climate, even the rainfall which are falling is very erratic in pattern. So you find that it comes sometimes in very large quantity over a small period of time and it goes away. So the only way to go in farming is irrigation. That's why I'm trying to do irrigation so that we want to see which one with combined with the fertilizer is actually the best so that farmers can actually adopt. But if you want to depend only on rain, I think farming will not be a very good business for you. But farming is very good. You need to adopt irrigation. However, for our small older farmers, where maybe they cannot afford the drip irrigation, I advise maybe you can start with furrow. Furrow is not a very bad method also. You can start with it. If you gain maybe some small capital, then you can invest in the what? In the drip. But you can start. There are also other methods of irrigation, maybe like conventional method. You can also try to use them. Small, you can catch up. Then later on you can invest on the drip because it's more water efficient. Even if you don't have water, you can use the harvest. You can harvest water from the roof of the building. You have your plantation.
Okay. Yeah. Thank you so much, Mr. Andrew.
Okay, thank you so much, Dennis.
And
Thank you so much.
thank you for the good work you have done over here. We hope it will help the department and the people around as they learn a lot from it.
Okay, thank you.
Okay.
Thank you.